तो टॉपिक जो हमें चैप्टर 2 में रहा था वो करेंगे, दैट इज कॉमन पोटेंशियल। लेट अस सपोज दैट वी हैव two capacitors C1 having capacity C1 and C2 which have charges Q1 and Q2 respectively. Okay, now the charge on the first capacitor will be Q given by Q1, let its potential be V1, that will be equal to C1 V1. Okay, now this potential be V2, then charge on it will be Q2, that will be C2 V2. As we know, applying the formula Q equal to C, you see. Now total charge when they are separate, they are not connected, okay, we get total charge which is equal to Q1 plus Q2, that will be C1 V1 plus C2. Now let us connect them, say in parallel. We have connected them in parallel. Now what will happen? Now assuming that V1 is greater than V2, that is capacitor C1 is at higher potential as compared to capacitor C2, then the charge will flow always from higher potential to lower potential. So charge will flow from Q1 to Q2, C1 to C2 till they acquire a potential which is common to both, that is called common potential. That is V. So charge will flow, since V1 is at higher potential as assumed, the charge will flow from C1 to C2, capacitor C1 to C2 till they acquire common potential. Both will have a common potential, that is V. Okay, so total charge after they are connected will be equal to again assuming that there is no loss of charge, there is only a redistribution of charge, Q dash plus Q2 dash, that will be C1 इस पे पोटेंशियल है V अब कॉमन एंड कैपेसिटर 2 पे C2, ठीक. सो since there is no loss of charge, then there will be this charge must be equal to this charge. So total charge before connection is equal to charge after connection. That is, this equation will be equal to this equation, that is इसमें common C, that is C1 plus C2, इसमें V हमने common निकाला, V the common potential, so यहाँ पर C1 V1 plus C2 V2, or V common potential which both of acquire after connecting will be equal to C1 V1 plus C2 V2 divided by C1 plus C2. Okay, now C1 V1, that is charge on the first capacitor, because we know Q is equal to CV. Therefore C1 V1 be charge on first capacitor, C2 will be charge on total capacitor, second capacitor, and C1 plus C2 as they are parallel will be their total capacity. Okay, so is equal to total charge divided by total capacitance. Now ये हमारे पास जो इक्वेशन है यहाँ ये वाली, इसको हम थोड़ा अरेंज करेंगे. C1V C2V C1V प्लस C2V इज इक्वल टू, इसमें हम फिर से देखेंगे C1V1 प्लस C2V, C1V1 प्लस C2V2. Now इसको हम इस साइड में ले जाएंगे और इसको इस साइड में, सो -C1V1 प्लस C1V, इसको इस साइड में ले जाएंगे, विल बी इक्वल टू C2V2 माइनस C2V, माइनस को कॉमन निकालेंगे और कैंसिल करेंगे, इट विल बी C1V1 माइनस C1V इज इक्वल टू, ये माइनस जब कॉमन निकाले ये प्लस बनेगा C2V माइनस C2V2. देखिए, this C1V1 was the charge on the first capacitor minus the charge which flowed to the second capacitor. This is the final charge on the second capacitor after connection. It was its first charge. So it means that charge lost by the first capacitor is equal to charge gained by the second capacitor. So charge gained, charge lost is equal to charge gained. Okay. Now we had assumed in finding the expression for common potential that there is no loss of charge. However, when we connect conductors or capacitors, then when they are connected, there is a loss of energy in form of sparks, in form of sound or heat. Some energy is lost. So this lost energy can be calculated. Okay, so we will take our next topic, loss of, यहाँ पर हम लिखेंगे loss of energy on sharing charges. Let us suppose that we have the capacitor or conductors, okay? Let us say one conductor having capacity C1 and another conductor having capacity C2. Now, when they are connected to each other, they acquire a common potential because charge will flow. Let us say this has a V1 is at higher potential and this is V2, secondly this is at lower potential. So charge will flow from capacitor C1 or conductor C1 to C2 till they acquire a common potential. We have already found that common potential V is equal to C1V1 plus C2V2 divided by C1 plus C2. Okay. Now, before they shared this charge, let us what was their total energy? So the energy shared before sharing charge. इसकी एनर्जी क्या है हमें पता है, इट इज 1/2 C1V1 स्क्वायर. इसकी क्या थी, +1/2 C2V2 स्क्वायर. नाउ जैसे हमने इनको कनेक्ट किया तो चार्ज डिस्ट्रीब्यूट हो गए, तो विल सी एनर्जी आफ्टर जैसे इन्होंने मतलब हमने कनेक्ट किया तो अब न इसकी V1 पोटेंशियल रहेगी न इसकी V2 रहेगी, अब दोनों की कॉमन पोटेंशियल रहेगी. तो तब उनकी एनर्जी क्या होगी, तो टोटल एनर्जी आफ्टर शेयरिंग तो U2 विल बी इक्वल टू, यहाँ पर लिखूंगा मैं, U2 विल बी इक्वल टू, आप टोटल कैपेसिटेंस है C1 प्लस C2 इंटू 1/2 टोटल कैपेसिटी इंटू पोटेंशियल, जैसे यहाँ पर दैट इज V स्क्वायर, क्योंकि अब कॉमन पोटेंशियल है इस सिस्टम का V. नाउ we can substitute from equation 1 for V in this equation. We get U2 is equal to 1/2 C1 plus C2 V स्क्वायर के बाद में लिखेंगे C1V1 plus C2V2 divided by C1 plus C2 whole square. ठीक. Now we simplify it, and after simplifying it, we first of all find the end difference. Now U1 minus U2. यानी पहले क्या एनर्जी थी बिफोर शेयरिंग और आफ्टर क्या एनर्जी थी आफ्टर शेयरिंग. अगर ये पॉजिटिव निकला दैट मीन्स u1 is greater than u2. अगर नेगेटिव निकला then u2 is greater than u1. That means gain energy. वो तो पॉसिबल नहीं है. अगर ये पॉजिटिव निकला that means u1 is greater than u2. That means energy is lost. Now u1 minus u2, जब हम इसको evaluate करेंगे, that is change in energy after sharing the charges, it comes out to be C1 after simplifying. Okay, you can do that simplification by yourself. C1 C2 V1 minus V2 whole square divided by 2 C1 plus C2. Now V1 minus V2 is a square, so it's a positive quantity. Capacity is always a positive quantity and their product is also a positive quantity. 2 is positive quantity, C1 plus C2 is also a positive quantity. Hence U1 minus U2 is greater than 0, implies that U1 is greater than U2. तो U1 तो एनर्जी बिफोर शेयरिंग, U2 एनर्जी आफ्टर शेयरिंग. तो आफ्टर शेयरिंग में जब एनर्जी इस सिस्टम की रहती है वो कम हो जाती है. सो देयर इज अ लॉस ऑफ एनर्जी when two bodies share charges. Okay, so loss of energy in form of heat, light, sparks, okay, even sound also. So this was all about common potential. Okay.